We all take our microwave ovens for granted nowadays, don't we? But where would we be without our microwave ovens? We sure couldn't heat a hot cup of coffee in 30 seconds. And I don't know about you, but I love my microwave. Hello again, Speech 100. I'm Kevin Hubbard, and today I'm going to be telling you how your microwave ovens work to heat things up. The idea behind using radiation to heat food was arrived at accidentally. In 1946, Dr. Percy Spencer was conducting radar-related research with the Raytheon Corporation. One day, while testing a magnetron, he noticed the candy bar in his pocket had melted. The magnetron is a vacuum tube they used to control the flow of electrons and generate microwaves for radars. So they could shoot microwave radiation out, bounce it off an aircraft or a ship, and get a return, a radar. I'm not sure about you, but I think I'd be pretty concerned if I was testing equipment that involved generating radiation and something in my pocket started heating up, because that would imply that I'm going to start heating up. So, what heated up the candy bar? And the simple answer to that is that microwaves heated the candy bar. Which begs the question, what are microwaves? A microwave is an electromagnetic wave, and it's between 300 megahertz and 300 gigahertz, so it falls between radio waves and infrared waves in the center of the magnetic spectrum. Right here, and you see radar listed, and radio waves, infrared. So how do microwaves heat something? They heat things through a process called dielectric heating. First of all, the microwaves are generated with through a magnetron with an electric and magnetic field around them. And when the waves pass through food or liquid, they cause the water molecules to rotate and align with the constantly alternating fields of the microwaves. Microwaves use a frequency of 2.45 gigahertz, so that means that the waves are alternating at 2.45 billion times per second. The water molecules rapidly rotate, and it causes molecular friction and heat. So as the microwaves shoot through any substance that has water molecules, these dipoles switch back and forth between positive and negative, and with a common microwave oven that's at 2.45 billion times per second, they oscillate. So what that is molecular friction causing heat. So simply put, microwaves excite the water molecules in the food or the liquid, and they start them spinning, and as they spin they get warmer. The same way if you rub your hands together, you generate heat through friction. So back to Raytheon. It wasn't long after the scientists understood this process of dielectric heating that they introduced the first oven. In 1946, Raytheon patented the process and released the radar range. It was huge, and it was expensive. It was for commercial use only. It cost between $2,000 and $3,000, and that was a pretty substantial amount of money in those days, since the average new car sold for about $1,500. It took Raytheon until 1965 to compress that down and finally release a countertop version, and that was the basis for all of our modern microwave ovens. You can see it looks pretty much the same as the ones nowadays, except for the analog readouts. The Amana radar range. So now you all know a little bit about the technology that's behind your microwave ovens, and you learn that it's not really that modern, mid-20th century. So hopefully you followed along with those technical bits, so now you can understand how microwave ovens really work. Thank you.